Okay, here we go. Section 11.2, areas of circles and sectors, found in your book here at page 602. So the first idea we need to talk about is the idea here of this area of a circle. So the area of a circle is how many square units it takes to fill it in on the inside. So as you can see, if I'm just talking about square units, if I'm just talking about squares, if I was to divide this up evenly into squares, do you see how it's going to be a lot of parts of squares because you're going to have these little bitty parts here. Okay, so you're going to have all these little bitty parts here around the outside. Okay, so it's not going to work out to a pretty even number. Okay, so it actually ends up working out to a unit of pi. Okay, and it actually comes from the idea of cutting that circle. If I was to take this circle and cut it into sectors. So if I was to take it and cut it into, what's going on there? Okay, and cut it into sectors, here's my center, and I was to cut it into all these little sectors. And if I was to line up all of these sectors end to end, like if I was to take one sector here and then put the other one here and then the other one here, actually what it ends up making is a parallelogram. Okay, and this parallelogram has a length here that's the same as the circumference. So again, it's going to have that pi in it. It's the same as the circumference all the way around this circle. Okay, and then the height here, the height of this parallelogram here is going to be our radius. So our area of a circle is pi times the radius squared. And it just comes from that idea of getting that parallelogram. So really this is something that needs to be remembered, memorized. The area of a circle is pi r squared. Okay, so if I want to find here, in extra example 1, okay, find each indicated measure. So here I want to find the area of a circle with a radius of 8 inches. So here's my radius. So I write my equation first. Area equals pi r squared. So I'm looking for the area, so I plug in my information, pi times 8.5, so times, and then I need to square that. Okay, so I type in my calculator 8.5 squared, and we get 72.25, so it'd be 72.25 times pi. So that's the exact, and since I'm dealing with area is measured in square units. So my area here would be, since I'm in inches, right, we've got inches right there. Okay, okay, we have got inches, so my units here would be square inches. And a lot of times, again, with measurements, we want approximately, so I'm going to take my 72.25 and multiply it by pi in my calculator, and I get 226.98 square inches. So again, we want both of those answers there. Okay, right, okay, here part B. So here I want example here, B. Okay, so the diameter of a circle, so we're trying to find the diameter, so we're trying to find something different here. Diameter of a circle with an area. So this guy right here is our area, that's our A. So I'm going to need my area equation is pi r squared. My area is 153.94 square feet equals pi times radius squared. So I need to solve for area first, because remember diameter here is 2 radii, so I need to find, the radius first. So I'm going to divide both sides by pi. So then r squared would equal 153.94 divided by pi. And then I need to take the square root of both sides. So now I'm going to type in my calculator the square root of 153.94 divided by pi, all inside the square root. And I get a radius of 7.000, so pretty darn close to 7. So then my diameter would be 2 radii, so 2 times 7 is 14. And my units here are feet, so my diameter is 14 feet. Okay. The area of circles and sectors are used often in population density. Population density is how dense is the population. If we look at the amount of people living in, let's say, South Dakota, as opposed to the number of people living in, let's say, California, the population density is very different because we have much fewer people over a much larger area, okay? So really, this population density takes into consideration the number of people in the area of land. So the population density is equal to the number of people, why can't I get that out, divided by the area of the land that they all reside in, okay? So there's our formula for population density. It's normally given in, population density is normally given in square miles. So the area of land here is normally in square miles. But in some cities, a lot of times it's used in other units such as city blocks, or in more dense areas and even acres. Less dense areas, acres and so forth and so on. Okay. So here we have, here an extra example 2 right here. Okay, we have about 124,000 people live in a 2-mile radius of a city's post office box. So we know here this many people, so there's our number of people, live here in a 2-mile radius of a city's post office. So for example here, if here's my post office, if I was to measure out 2 miles and think about everybody that lives inside those 2 miles, there's 124,000 people that live, 124,000 people live inside this circle right here. Okay. People. Okay, so we want to find the population density in people per square mile. So the first thing I need to do is find the area of this circle, meaning what is the area of this land where all these people live. So I need to find the area of that circle. So first let's find the area of the circle. The area would be equal to pi r squared, which is pi times 2 squared, that's in miles. So 4 pi square miles. Okay, so now population density would be equal to the number of people divided by the area, which is 4 pi square miles. So again, my units, the units up here for this guy up here, the units for that is people, the units for here is square miles. So I'll get people per square miles. So now if we go ahead and do the division, I'm going to take 124,000 and divide it by, again, when I'm doing this my calculator, I need parentheses around this thing. So my calculator divides by both the 4 and the pi. And we get approximately 9867.6. And this would be people, that's an O, per mile squared, per square mile. So for every square mile, there are 9,867 people, okay? That does not happen where we live. I don't even know if that many people live in the county, okay? So the square mile, we are not that densely populated, okay? So let's go here now for part B, okay? So now here, number B. Part B, a region with a 10-mile radius. So a region here, we have our 10-mile radius, has a population density of about 869 people per square mile. So that's our density. We want to find the number of people who live in the region. So again, our equation is population density equals the number of people divided by the area of the land. Well, I know the population density. I know this guy right here. The population density is 869 people. So this is 869 equals, we're trying to find the number of people. So let's have that be my x. All over the area, it's a 10-mile radius. So the area, that would be a circle. So it would be pi times 10 squared, 10-mile radius. Okay. So if we simplify it, let's bring it over here. So we'd have 869 equals x all over 100 pi So now we need to multiply both sides by 100 pi. So those cancel. So then x would be, if we do approximately equal to 100 times pi times 869, approximately 273,004, and that is the number of people that live in that area. Let's get rid of that. I don't know what that is. 273,004 people live in that area, in that region with an area of 100 pi square miles. All right, next one, sector of a circle. Okay, so the sector of a circle, again, is a piece of a circle. So a sector is, again, like our central angle. The sector is all the stuff inside, all of the stuff inside here. So here's my sector. Okay. So if we're looking, so the sector of a circle is a region, is a formal definition, it's a region bounded by 2 radii, okay, of a circle. Okay, so it's just this area bounded right in here. So right in there is my sector. The area of a sector, again, is the number of square units it would take to fill this. Okay, it's the number of square units it would take to fill inside of there. So again, the area of this sector, the area of the sector here, is going to be in relation to the area of the whole entire thing. So to figure out what part of a circle this is, I would need to know this angle here, this angle theta. Okay, so the area of that sector, okay, and we use the points of the sector. If this was point A, P, B, we would call the sector APB, a lot like a central angle. So the area of that sector, so the area of sector APB would be equal to what part of the whole circle is this? So basically, I would need to know the measure of that arc, the measure of arc AB, or this angle right in here, this angle right in there, that angle, compared to the whole circle, which is 360. So the part of the circle times the area of the whole entire circle, pi r squared. Okay, do you see that's very similar to when we talked about the length of that sector? Remember we talked about the length of like this sector right here? The length of that arc, the length of this arc. If I'm talking about the length of this arc, again, it's that part of the whole entire arc, which is 360. So it's the same idea here. Okay, so here we want to find the areas of the sector formed by angle PSQ. So we're trying to find the area inside this guy right here. So to find the area of that sector, so to find the area of sector PSQ, I take what part of the whole circle? It's 135 degrees of the whole 360 times pi r, which is 15 squared. So I would need to take 135 divided by 160, 360, excuse me, divided by 360, which gives me 3/8. So I need to take then the 3/8 times the 15 squared times the pi. So 3/8 times 15 squared gets me 675 over 8 pi. And that would, again, that's area, so that would be in square centimeters. Or the approximately, take that times pi, is 265.1 square centimeters. Okay. Oh, geez. Okay. Now let's go ahead and let's look at here, extra example 4 over here. Find the area. We want to find the area of the whole entire circle. So we want to find the area of this whole circle, the whole entire circle. We know the area of this sector, we know the area of this sector in here is 48 square feet. Okay, so I know the area of the sector. Let's write that equation down. So we have the area of sector PSQ SQ would be equal to, again, what part? 135 out of 360 times the area of the whole thing, which is what we're trying to find. So I'm going to use uppercase A for that, for the area of the whole thing. And I know the area of sector PSQ. I know that's 48. So we have 48 equals 135 over 360. Oh, that should be a 5. And just 35 divided by 360 times A. So I would need to multiply both sides by the reciprocal, 360 over 135. Okay, these will multiply out, so my area would equal to, take 360 divided by 135 times 48, 128 square feet for the whole entire thing. So there we talk about areas of sectors, and again, a sector is just a piece of a circle. I always like to think of it like a piece of pie. It's a piece of that circle. Okay, next one. Okay, all right, so here we go. A farmer has a field. It's a very interesting field. And a field could actually be shaped like this if we had just a square section and then two half pivots. And then 2 half pivots, which is done a lot more in the south than up here. We don't irrigate quite as often in our area. We don't have enough water to irrigate. Okay. But here we have a farmer with a field with the shape shown. We want to find the area of the shaded region to the nearest square meter. Okay, so to the nearest square meter. So first, I'm going to look at this square right in here. It's a square here because we have opposite sides, congruent, and then these two sides are both 8. Okay, so I know then that these two sides are also both 8, so these are all congruent. So the area inside here would be 8 by 8. So the area inside here would be 64 square meters. That's just the area inside this square. Okay, but now if we look, if I take these two circles, if I take this circle right here, and put it together with this circle right here, and half circle, we would make one full circle with a radius of 4. Because if we notice here, this radius here would just be 4. Okay, so we'd have one full circle with a radius of 4. So here I'm going to find the area of the circle. So the area, I'm going to go sub C. That's the area of the circle would equal to pi r squared. So it'd be pi times, pi times 4 squared. So it would be the area of those two circles together would be 16 pi. So the area of the whole thing would be the 64. Oh, that's square meters in there. I missed that right in there, and that units right in there would be square meters. 64 plus 16 pi. And it says, I want to round it here. Again, it says here to the nearest square meter. So I would need to take 64 plus 16 pi, and I get 114.265, and then again that would be square meters. So we want it to the nearest square meter, so that would just be 1 meter right there. So look behind it, it's a 2, so it'd be 114 square meters. Again, that is an approximately because we did a fair share of rounding.